Okay. So today we start the functions of two variables. It's Taylor series expansion and maxima and minima for that function. Okay. So now we have the function. This is your Taylor series for functions of two variables. Okay, so let me have the function depending upon x and y. X and y are two independent variables. Okay.
Yes.
So now let the value of x is changed to x plus h and the value of y is changed to y plus k. So after this I have the value of the function at fx plus h and y plus k. So you know what is there in Taylor series. I am having some expansion of fx plus h and y plus k in terms of f x and y. Okay. So just for a recall, if f was a function of one variable, then you know fx plus h is equal to fx plus h f dash x plus h square upon factorial 2 f double dash x plus h cube upon factorial 3 f triple dash x and so on up to infinity. So this is the Taylor series for a function of one variable. Is it clear to all of you? Right. Now I shall be applying the same thing repeatedly, first for one variable, then for second variable, to get the final Taylor series extension for this function of two variables x and y. So now right. So now I am having the function fx plus h and y plus k. The value of function f at point x plus h and y plus k. So now let me consider x plus h to be the constant value, and let me make the Taylor's expansion with respect to the variable y. Right? So of course the differentiation will be transformed to partial differentiation, because I am having x as constant. The derivative will be with respect to y. That is a partial derivative. So this will be written as fx plus h comma y, right, plus k. The increment in the value of y is k. This is k, and then the derivative del over del y of the function fx plus h comma y. Right, and plus k square upon factorial 2 del square over del y square of fx plus h y, and so. Is it clear? So now coming back at fx plus h and y, this can be written as, now treating pi as constant, this will be now fx plus h del over del x of sorry, I mean, right, this is fxy of fx y, okay, plus h square upon factorial 2 del square over del x square of fx comma y, and plus, and so on. Is it okay? So now replacing the expression for this fx plus h comma y with this expression, bring here. Okay. here you are having fx plus h at y and y, fx plus h comma y, fx plus h comma y. So in place of fx plus h y, put this expression, that is fxy plus h del over del x, fxy plus h square upon factorial 2 del square over del x square fx comma y, and so on. Is it okay? So this will be fx comma y plus h del over del x fx comma y plus h square upon factorial 2 fx comma y plus k del over del y of fx comma y plus h del over del x fx comma y plus h square upon factorial 2 f at x comma y. Is it okay? Next term, plus k square upon factorial 2 del square over del y square of fx comma y plus h del over del x fx comma y plus h square upon factorial 2 fx comma y, and plus and so on, and further terms will appear in the similar fashion. Is it okay? So now you see here that further terms there will be a third order derivative terms.
Yes, sir.
There will be third order derivative terms. So let me have some manipulation up to second order, and for the further derivative the same thing can be done. So let me complete the manipulation for up to first order and then second order. Is it okay? Now see here, this term fx comma y, it is without any derivation, so this will appear. All other terms are some derivative of function f with respect to either x or
Y.
y. So in this way I shall get fx plus h y plus k, this is equal to fx y and plus first order derivative term. This is h del f over del x, and okay, I think it is missing here, del square over del x square. Okay, this is h square, I del square over del x square, again this is del square over del x square. So the first derivative h del f over del x, and from here, from second term, this is k del f over del y. So this is, now write down it like this, h del f over del x plus k del f over del y, plus coming to the second order derivative, this is h square upon factorial 2 del square f over del x square. This term come here, this is del over del y, this is del over del x, this is again another term of a second order derivative, right? Now this is del over del y, this is del square over del x square, it will become a derivative of a third order. So I am omitting it. Now coming to this expression, this is k square upon factorial 2 del square over
Del Y.
del y square, so it is del square over del y square. Okay?
Yes, sir.
And similarly, this will be now
Third
order derivative, this will be
Fourth
fourth order
order
derivative. So this one, right?
Yes.
So these three terms will be appearing for the second order derivative. So here it is 1 upon root 2, that is nothing, alright. Here it is upon 1 upon root 2. What is the value of 1 upon root 2? This is 1 upon 2. Sorry, factorial 2. I'm sorry, this is factorial 2. So the value of factorial 2 is 2. So taking common 1 upon factorial 2, you will be having inside h square del square f over del x square plus twice, now twice will be there, twice hk del square over del x del y fxy plus twice hk del square f over del x del y and plus this will be k square del square f over del y square, and further there will be the terms of third order derivatives, fourth order derivatives and so on. Is it okay?
Yes.
Clear to all of you? Right. So in the operator form, it can be simplified as this is equal to fx comma y plus h del over del x plus k del over del y of f plus this will be 1 upon factorial 2 h del over del x plus k del over del y its square operating over f, and similar fashion you can write down more terms 1 upon factorial 3 h del over del x plus k del over del y power 3 of f and so on. So in this way you get the Taylor series expansion of a function of two variables. Is it okay? Clear to all of you? Is it fine? So in this manner you can find out the Taylor series expansion for a function of two variables. Is it clear to all of? So this must be memorized, right? So after this, now I move to the topic of maxima and minima for a function of two variables. Now the next topic is maxima or minima for a function of two variables, and of course let fx comma y be the function for which we are going to investigate the existence of point of a मैक्सिमा और मिनिमा. ठीक है ना, यानी कि fx को y फंक्शन है, उसके लिए कोई पॉइंट निकालने हैं हम लोग को जिन पर की फंक्शन का मैक्सिमा या मिनिमा आकर करेगा. ठीक है ना. तो बिफोर गोइंग फॉर इन्वेस्टिगेशन फर्स्ट लेट मी डिफाइन द पॉइंट ऑफ मैक्सिमा एंड पॉइंट ऑफ मिनिमा इन केस ऑफ टू वेरिएबल्स, राइट. नाउ let a comma b be a point on the plane. Then this point a comma b is called point of maxima or point of a minima if there exists some neighborhood of this point a comma b inside which if the value of the function at this point a comma b is greater than or equal to the value of the function on other points inside that neighborhood, this will be a point of a maxima. And if the value at this point is minimum, then that will be point of minimum, right? Yes. So I write down here, let a comma be a point on plane if there exists a neighborhood, let me say D of a comma b, how such that number one, f x comma y is always less than equal to f at a comma b for all values of x belonging to D. If fx comma y is always less than equal to f at a comma b for all values of xy belonging to D, then a comma b is called point of a, this is called a point of a maximum because the value is the highest at this point. So then a comma b is the point of maxima. And second, if fx comma y is greater than or equal to f at a comma b for all values of x comma y belonging to D, then this is a point of a minima, right? Then a comma b is the point of minimum. So this is the definition for the point of maximum or minimum for a function of two variables. ठीक है ना? यानी कि किसी भी पॉइंट a कोमा b को हम लोग मैक्सिमम का पॉइंट बोलेंगे अगर उस पॉइंट पर जो इतने उसके आसपास के कुछ पॉइंट्स हैं, एक नेबरहुड ऐसी मिल जाती है कि आसपास वाले उस नेबरहुड में जितने पॉइंट्स हैं उनके रिलेटिव उस पॉइंट पर फंक्शन की वैल्यू क्या है? मैक्सिमम है। तो पॉइंट ऑफ मैक्सिमम, ये पॉइंट ऑफ मिनिमम, ठीक है ना? और अगर उस पॉइंट पर वैल्यू जो है उस नेबरहुड के आसपास के सारे पॉइंट्स पर जो वैल्यू है वो सबसे कम है, देन इट विल बी पॉइंट ऑफ मिनिमम और मैक्सिमम, ठीक है ना? तो अब हम लोग को इन्वेस्टिगेट करना है, जैसे हमने वन डायमेंशन वेरिएबल के लिए किया था, फर्स्ट ऑर्डर डेरिवेटिव टेस्ट था, सेकंड ऑर्डर डेरिवेटिव टेस्ट था कि किस पॉइंट पर हमारा मैक्सिमा होगा और किस पर मिनिमा होगा। तो वो सिमिलर टाइप ऑफ इन्वेस्टिगेशन हमको फंक्शन ऑफ टू वेरिएबल्स के लिए भी करना है, ठीक है ना? तो सबसे पहले हम लोग लेते हैं फर्स्ट ऑर्डर डेरिवेटिव टेस्ट। First order derivative test, right? Let fx comma y be the function of two variables. Of course it is differentiable, continuous and all that, that is pre-assumed. Okay, so fx comma y is a function of two variables and let a comma b be the point of either maxima or a minima. Is it clear? So now you consider g of x is equal to f at x comma b. Put y is equal to b. So now this is a function of x only. If the value of x is varying, the value of fx comma b that is taken as dx is also varying. So let me investigate the value of maxima or minima for this function g of x. अगर पॉइंट x is equal to a पर इसकी वैल्यू मैक्सिमम है या मिनिमम है x इक्वल टू a पर gx की वैल्यू क्या होगी, gx के लिए क्या होगा, फर्स्ट डेरिवेटिव 0 बनेगा। भाई जो फर्स्ट डेरिवेटिव g डैश x है, ये हमारा रिजल्ट कहां से आया, वन वेरिएबल के फंक्शन से। अब यहाँ पर तो क्लियर कितना वेरिएबल है, सिंगल वेरिएबल है ना, ओनली x इज हियर। सो इफ x is equal to a is point of maxima or a minima, so g dash at a, this will be equal to 0. Fine?
Yes, sir.
So now what will be g dash a? This will be nothing but del f over del x at a comma b, right? So this will be equal to 0. And similarly, taking h of y is equal to f at a comma y, I shall have h dash b, that is nothing but del f over del y at a comma b. This will be equal to 0, right?
Yes, sir.
Is it okay?
Yes, sir.
So in this way, del f over del x is equal to 0 and del f over del y is equal to 0 at point a comma b. Is it okay? So this is the first order derivative test. If I need to find the points of maxima or minima, then I may solve these equations. Del f over del x is equal to 0 and del f over del y is equal to 0, and I shall get the points
Maxima.
over which maxima or minima or something else that may exist. तो दो वेरिएबल के फंक्शन के लिए क्या करना है आपको, फर्स्ट और डेरिवेटिव दोनों पार्शियल निकालो, उनको इक्वल टू 0 करो, वैल्यू क्या बनेगी, जो भी x और y के लिए सॉल्यूशन आएंगे उन सॉल्यूशंस पर ही मैक्सिमा या मिनिमा एग्जिस्ट करेगा। तो वहां मैक्सिमा होगा या मिनिमा होगा, उसके लिए हम लोग लगाएंगे सेकंड ऑर्डर डेरिवेटिव टेस्ट। इज इट क्लियर? तो सेकंड ऑर्डर डेरिवेटिव टेस्ट के लिए कैसे करना है वो हम लोग करेंगे नेक्स्ट क्लास में, राइट? सो टुडे वी स्टॉप हियर, फाइन।